So in case you're interested, I'll just talk about where this formula comes from, because it's not as though somebody discovers it by the side of the road. But let's just talk about the fact that we're looking for this. We're looking for a sum of a geometric series. And you know, a geometric series starts with the first term, which we call a sub 1. And then every single term we get by multiplying by r. So the second term is ar. Then we have ar to the second, then ar to the third, and then right, ar to the fourth. And this goes all the way until we get to the nth term, which we call a1r to the n minus 1. And notice this goes to the n minus 1, but there are going to be n terms. Like if we stop at r to the second, we have 3 terms there, right? So the number of terms we have includes the fact that we have that first one that doesn't have an r. So I'm looking for the sum of n terms, and I'm going to write that as a sub 1 plus a sub 1r, a sub 1r squared, a sub 1r to the third, and all the way to a sub 1r to the n minus 1. And now I'm going to do something tricky. I'm going to take this sum, both sides of this equation, and I'm going to multiply it by r. So I'm going to have r times s sub n. So my first term is going to be, I'm going to have a sub 1 times r. I'm going to just put that over here. And then my next term is going to be that thing times r, which is a sub 1 times r squared. And then I'm going to have a sub 1 times r cubed, and so on and so on and so on. But let's look at what happens when we get to this. I'm going to have a sub 1 times r to the n minus 1 times r. And the exponent on r right now is 1. There's nothing there, so I'm going to assume it's 1. And you know from all the algebra you've done that when you have the same base, you're going to keep the base and you're going to add the exponents. So you're going to have n minus 1 plus 1. So that's just going to give us a sub 1 r to the n. This is a 1. A sub 1 r to the n. So here I'm going to have a sub 1 r to the n. Okay, now before that, the term before it is still going to be a sub 1 times r to the n minus 1, right? Because if I go in this direction, the exponents go down. Okay, so here's what I'm going to do now. What I'm going to do, let me get rid of that. What I'm going to do is I'm going to do this side minus this side, right? So in other words, I'm going to take my equation for s sub n, and from that I'm going to subtract r times s sub n. And notice what's going to happen. A sub 1, I'm going to have a sub 1, but this minus this cancels out. Everything is going to cancel out except for the a sub 1, and then I'm subtracting a sub 1 r to the n. And I'm going to do a little snazzy thing here. On the left-hand side, I'm going to factor out the s sub n's, which is going to leave me with 1 minus r. And on the right-hand side, I'm going to factor out the a sub 1's, which is going to leave me with 1 minus r to the n. And since I want s sub n by itself, I'm now going to divide by both sides by this 1 minus r term. So s sub n is a sub 1, 1 minus r to the n over 1 minus r.